So let's take a look at working with the expansion properties of logarithms. You will notice the directions. First off, give us a hint of what they want us to do, expand. So that kind of helps us. If you're looking at the argument, you'll notice that the argument of this natural log is a little more complicated. And remember, with natural logs, the base is e. And so I'll pick out a few characteristics of what I see. The first off is I see radicals in the argument. And whenever I see radicals in the argument, before I even deal with the expansion properties, you may be or find it a lot easier, more easier to work with if you can rewrite them as rational exponents. And so we're going to pull from a property in our past. Remember, we had x to the, I'll do it this way, the nth root of x to the m can be rewritten as x to the m over n. So right away, when I see this power of 3, I should say, radical with index 3, I'm going to rewrite it as natural log. Still numerator is 8x plus 1, but instead of the cube root, I'm going to rewrite it so that entire expression is taken to a power of 1/3. So I'm going to have x minus 4. That's multiplied with 2x plus 5. So now it's kind of up to you how you want to deal with this. You could either look at the fact that you have a fraction and then break it apart. Sometimes what I like to do when I'm going through this is I may actually simplify the rational exponent a little bit more. So I still have natural log 8x plus 1. But if you remember one of the properties, if you had a factor taken to a power, I'll just use it as a n, I suppose, then you can raise each factor to that power as well. So that denominator of that argument, both of those factors are taken to the 1/3 power. So I can see that I have x minus 4. I can raise that to the 1/3. That's still multiplied by 2x plus 5, also raised to the 1/3. And when I do this, it kind of makes it a little bit nicer for me to break up using the properties of expansion. So at this point, I can now work with the expansion. And the fact that I see a fraction, this is us using the log of a over b. Maybe I should do x over y. I think we were using b in our example. So whenever you see a fraction in your argument, you know that the logs will break up so that it's a subtraction of 2 logs. So log of the numerator minus log of the denominator, same base. So we can take that root. So let me move this over a little bit so that we can see it. I have to use an arrow because I have my properties in the way. So I see, just so that you see what I see a numerator of 8x plus 1, and I see a denominator of factors. So when I rewrite it, I will be using the natural log. So this will be the natural log of the numerator, which is 8x plus 1. And I will be subtracting off the natural log of the entire denominator. So let's look at this a little more carefully. This is the natural log of x minus 4 to the 1/3. And it's still multiplied by 2x plus 5 to the 1/3. So just kind of inspect what's happening. You broke up your logs into a difference, so the 8x plus 1. And then now we have the entire log of the entire denominator. Now we have expanded it, but we have not expanded it completely. The natural log of 8x plus 1 is good to go because the only thing that you have is a binomial or a sum of terms. It is the second part, the pink version, natural log of a product. We're going to use the property one more time. When you have the log of a product, if you remember, the log of a product breaks up into a sum of the two logs. So that pink part, I'm going to break up just a little bit more. That is saying natural log of x minus 4 to the 1/3 plus natural log of 2x plus 5 to the 1/3. Let me draw a little line so that we don't get confused with our properties. But I need to be extremely careful because the pink version expanded. Look at what was in front of all of this was a negative sign. So you have the entire expansion to deal with. Still rewriting natural log of 8x plus 1. So what really happens? We could check it out in terms of we'll be distributing this negative sign. So negative log, negative log. So natural log of 8x plus 1 minus natural log of x minus 4 to the 1/3 minus natural log of 2x plus 5 to the 1/3. Now we feel pretty much expanded. The only other thing we have to deal with is, if you will notice along with me, I do see some exponents in the argument. So that's one more property to look at. Remember what that property, log base x to the r, I see there's a b, that allows us to move that exponent along to be the coefficient of the log. So this is what we'll have to do for each of those to be considered to be expanded completely. So one last step, we have natural log of 8x plus 1 minus the 1/3 now becomes the coefficient, natural log of x minus 4 minus, again, then 1/3 becomes the coefficient again, natural log of 2x plus 5. And now we have expanded our logarithm completely. So that's wonderful. Some of you may be asking why? Why should we be doing this? It makes it look a lot more complicated. Just consider where we started. So remember, we started off, and I'm going to rewrite it so that I'll look at it in terms of the natural log after we rewrote with rational exponents. So I'll start out with the 8x plus 1 over x minus 4 to the 1/3 times 2x plus 5 to the 1/3. So we started off with a log with the fraction, and we ended with an expansion of 3 different logarithms, same base, but different arguments and such. So just to let you know, the expansion does help us a lot with some of the higher level math classes, helps us make the math of the new concepts a little bit more nicer. Right now, it's more of an exercise with our brain so that we can, if we can expand, we can condense. Kind of helps us utilize the properties. And you may notice some patterns with the more you do these types of problems. If you want to look at this with me, you might notice a few things before you even have to kind of rewrite all the subtractions and the additions. I'll kind of help you see the idea. If you play along with me, notice that logarithms that have a positive coefficient, the factor or the argument was already in the numerator. So that kind of helps us out a little bit with positive logarithms. And logarithms that have negative coefficients, if you want to go back and forth, you can kind of see that these, you will notice, were factors of the denominator. So this could help us greatly with patterns. If you were interested, you could take it straight from the starting point, which I had, and go to this step at this moment. So if you're interested in shortcuts, you can play along. If not, you just take your time, work these out. But kind of the patterns, if you have positive logs, just one more time. Positive logarithm means the factor, means argument was originally, was in numerator. And if you have a negative log, the argument was a factor of the denominator. So the more you do this, the little faster it can become. Let's see if we can utilize this shortcut for some of the example 2. We're still in the same boat here. So let's take a look at this. Right away, you have a logarithm, the base is 4. And also notice that you do have a radical in the argument. So before we even start, let's rewrite. Log base 4. Notice this radical, in this case, it's covering the entire fraction. So if we rewrote it, the index of this square root, the index would be 2. So that leaves us with a 1/2 power. And it means that our factors, or the entire fraction, is taken to the 1/2 power. Now I color coded it. If you don't have extra colors, oops. If you don't have extra colors, you may use maybe brackets to help you out with that. So before I get excited about expanding, I'll do one more thing with some exponent laws. And I notice back in our past with the exponent laws, if you had factors and fractions taken to powers, and I think we did an xy or something like that, xy over z to the a. You basically raise each of the factors to that exponent and anyone in the denominator to that exponent. So that's what we're going to do with this, this kind of tricky argument at the moment. So log base 4, 9x plus 2 will be raised to the power of 1/2. Still multiplied by x plus 1, which is also raised to the power of 1/2. And that is all over x minus 5, also raised to the power of 1/2. Now keep in mind, I have a factor. That's why I wrote the dot to remind myself. Now that I'm in this form, I could utilize my shortcut. And I could say, okay, whoever has factors in the numerator, so that's this one and this one, should have a positive log. And whoever has factors in the denominator should have a negative log. So I could take my shortcut right away if you'd like. And remember, the base was 4, so everyone gets separated. So I have log base 4. We'll have 9x plus 2 to the 1/2. So that was a factor in the numerator, which is why it's positive. You don't have to write the positive sign, but it helps just to remember. Positive log base 4 of x plus 1, also to the 1/2. That was a factor that was in the numerator. That's why that logarithm will also be positive. Now, we had a factor in the denominator. So this is why that coefficient of that logarithm is going to be negative. So that will be rewritten, expanded as log base 4 of x minus 5 to the 1/2 power. And just reminding you, it was in the denominator, which is the reason for the negative coefficient. So now we're almost done. we just want to make sure we have one more rule to take care of. If you guys notice that there's exponents in each of the arguments, all we have to do is pull those around to the front to be considered fully expanded. So the final expansion would look like 1/2 log base 4 of 9x plus 2 plus 1/2 log base 4 of x plus 1, and then minus 1/2 log base 4 of x minus 5. And now we have expanded completely. So take more time, do a couple more examples so that you're fully comfortable with this, and I'll see you in the next example.